If we take a look at example 2, they don't tell us, or they don't show us the triangle, they just tell us stuff about it. So again, if you just assume, if they're naming things A's, B's, stuff like that, just assume the triangle name is ABC, and then put things where they belong based on the angle name, or the name. So I'm going to just draw just some generic ABC. A is 30 degrees, because they told me that, angle A is. They're telling me side B is 10.0 feet, so side B is opposite angle B, this is 10.0 feet. And side A is 4.50 feet, side A is opposite angle A, so this is 4.50 feet. So I do not know what side C equals. Okay? And I don't know what angles B and C equal either. So I'm missing 2 angles, missing one side. But again, I need to diagnose what I'm given so I know what scenario to use. So if I'm looking at this and diagnosing it, I got an angle and I got 2 sides. So what I've got here is a side-side angle setup. And that's law of sines, case 2. With side-side angle, law of sines, case 2, the very first step says use the law of sines to find the missing side you can, or sorry, the missing angle you can find. So if you take a look at the picture here, this angle and this side correspond to one another. This angle and this side correspond to one another, and then this angle and this side correspond to one another, right? Notice the C's. Do I know what side C equals? Do I know side C? Do I know angle C? So if I make a proportion with C over sine of C, and that's not going to be helpful at this point. So if I just focus on the ones that I do have information about. I know what A is, big A, angle A. I know what side A is. I know side B, I don't know angle B. So if I do that part of the law of sines, A over sine of A equals B over sine of B. And I just do the amount of law of sines that's going to be useful. Again, if I put this third fraction on, which says C over sine of C, that's of no help because I got a bunch of variables in there. It's not helpful. So I probably wouldn't even write that part yet. Okay. Then I'm going to get my calculator and ask my calculator what the sine of 30 is. And it's 0.5. So I get 4.50 over 0.5 equals 10.0 over sine of B. So again, I'm just creating a proportion, evaluating this, I'm just changing sine of 30 into what it equals. Again, my calculator knew what that was, I don't have to know what sine of 30 is. Any sine of any angle, your calculator knows those numbers. So, I cross multiply now, I'm going to get this product, 4.50 sine of B equals this product. I happen to know 0.5 times 10.0 is 5. If you didn't know that, obviously, 0.5 times 10.0 equals, let's say 5. So now I'm going to divide both sides by 4.50. So I'm going to do 5 divided by 4.50. That comes out to 1.111111. So if I'm going 4 decimal places, sine of B equals 1.1111. So anytime I get a side-side angle, expect this type of work to happen to start off with. Your initial goal, find an angle that you can find. In this case, we can find B. Okay? Get all the way to the point where it says sine of B is equal to some number. And then what we learned already about this look is if sine of B is equal to some number, then B equals the inverse sine of that number. Okay, so I go to my calculator, type in inverse sine of 1.1111, and that comes out to error domain. So, that's one scenario that happens when you do a side-side angle. The triangle is not possible. It's not possible to have a side that's 10 feet long with a 30-degree angle with this side opposite the 30-degree angle being 4.5. It can't happen. All right, so it's not possible. Okay, so when your calculator says error with what you're doing, that means that this is not possible, so we'd say no triangle possible. Okay, let me give you a visual of this if I draw it to scale, just real quick. Just sometimes people see a visual, it helps make sense. So I draw this thing to scale. If I get myself a ruler here, and I draw a side that is 10 feet long, so I'm going to make it 10 centimeters long. Okay. And then I draw a 30-degree angle up here. You can see here 30 degrees, right? Now I need to make a 4.5 centimeter segment come off of here that touches that purple line. Okay, so what I'm going to do is I'm going to make a circle. Okay, I'm going to position my circle center here, and I'm going to go out 4.5 centimeters, which would be right there. The circle doesn't reach the line. It's not possible to go 4.5 feet from this direction, any angle, to reach that line. It's too far up. All right. Now, if that angle were shorter, take a look real quick. Suppose I had a 20-degree angle instead of a 30-degree angle. Now we're looking at this, and notice there's two answers possible. Two places where 4.5 feet could be there, 4.5 feet could be there. That's why there's two sets of answers possible sometimes. It's also why there's no answers possible sometimes, because sometimes it's just not long enough to reach over there. All right? So, algebraically, we didn't have to see the picture to do this. Once we get to the point where sine is bigger than 1, it's not possible. Okay? Just know that anytime you're dealing with sine, anytime you do sine of anything, suppose I do sine of 80, 0.9848, sine of 85, 0.9662, sine of 89, 0.9998, sine of 89.9, 99999, sine of 90 is equal to exactly 1. If I go sine of 90.1, starts going back down. The biggest value sine can ever take on is 1. So if your sine is bigger than 1, it's not possible. So again, that's going to happen sometimes. The triangle is not possible because you'll get sine bigger than 1. So with a side-side angle, that's scenario 1 that could happen. You have exactly, or 0 answers. Okay.